Electric circuits. Vocabulary, Ohm's law, series grouping, parallel grouping. Students should be able to apply Ohm's law, draw circuit diagrams using symbols, identify series and parallel circuits, and describe the functioning of light bulbs in series and parallel circuits. We're going to start with the first part, which is about Ohm's law. Resistance, Ohm's law. Resistance is the measure of how difficult it is for charges to flow through an object. What did Ohm discover? Ohm performed the following experiment. The materials used for his experiment were a conductor R, variable DC dry cell, ammeter, voltmeter, connecting wires. The procedure is as follows. Connect the conductor in series to the DC dry cell. As you can see, connect an ammeter in series to the conductor to measure the current flowing through it. Connect a voltmeter in parallel across the conductor to measure its voltage and vary the voltage of the DC dry cell, and record in a table the values indicated by the voltmeter and ammeter at each value of the dry cell. So this is the dry cell. When the voltage of the dry cell was 9 volts, the voltage across the conductor was 9 and the current is 0.9. Now I'm going to vary the voltage of the dry cell to 13. The voltage across the conductor changes, it becomes 13, and the current passing through it is 1.3. Now I'm gonna put it on 16 volt, the voltage of the dry cell. The measured voltage across the conductor is 16, and the current traversing it is 1.6 ampere. And we do the same thing at 18 volts, as you can see, and at 20 volts. Now the values are recorded in such a table for each case, and U divided by I for each case is calculated. Here it is 100 volt per ampere. Okay, because U is in volts and the current is in ampere, and so on for all. So I can just write it here, V per ampere for all. All right, so U over I is constant. Then Ohm decided to consider this constant value to be the resistance R, and he stated Ohm's law as U equal Ri, because U over I equal R. So if we do cross multiplication, R mean R over 1. You can write it as such, R over 1. So U equal Ri. Then this is Ohm's law. And as a conclusion, he concluded that conductors have constant resistance regardless of the applied voltage. So whatever the applied voltage by the dry cell was, U over I, though U changed alone and I changed, but U over I remained constant. So here is a summary. This is the law, U equal Ri. And here you have a table that shows voltage symbol U, unit volt, symbol of the unit is V, current is symbol is I, and SI unit is ampere, and the symbol of the unit is A, capital A. Resistance are ohms, and this is the symbol of the SI unit. So this pyramid shows how we can use the formula either to find U or I, R or I. So if you're given U and R, we have to put U on the top and I R below. Okay, so U is equal, so if we want I, we have to hide it, then it's equal to U over R. If you're looking for R, then it is equal, we hide R and it's equal to U over I. If you want U, we hide U and it's equal to I times R. So these exercises are required to be solved.